In this video, we are going to discuss the definite integrations of an even function and an odd function. Imagine that you have a function that is even and you are asked to integrate the even function from minus a to a. Then the integration would be just simply equals to 2 times the integration of the functions from 0 to a. So if you represent this in the form of a graph, then this is what you get. This is an example of a symmetrical function integrating from minus a to a. That integrations would give the area of the curve from minus a to a. And it's very obvious that due to the symmetry of the function about x equals to 0, then the area on the left is just equals to the area on the right. Therefore, the total area, that is a sum of the two area, A1 and A2, then the A1 would be just equals to A2. Therefore, the total area is a sum of both, and it will give you the 2 times the area of one side. Either you call it A1 or A2. The total area will be just 2 times A1 or 2 times of A2. That is a very simple rule to follow. The things that you have to look out for is the integration should be going from minus a to a. However, if you have a symmetric function that is going from, say, for example, a to say 1.5a, then you cannot write this as 2 times the integration of f of a dA from 0 to a. This is wrong because integrations for the even function that follows this rule can only be applied if you are integrating from minus a to positive a. If the lower limit, upper limit are not the same except for a minus sign, then you cannot apply this very simple formula. So this is the integrations of an even function from minus a to a. Now imagine you have another function which is an odd function. So an odd function, if you were to integrate an odd function from minus a to a, where f is an odd function. Odd function means that f evaluated at minus x is equals to f of f, but with a minus sign. Okay, so in that case, the integration of the function from minus a to a would result in a values of 0, because for a function that is odd, for example, if the function is odd, then you have this kind of behavior. Say x equals to if you have a values of x here and the values of minus x here, due to the oddness of the function, the value here f at x1 would then be equals to the negative of f at minus x. You can see that if you are integrating the function from minus x to x, that integration from minus x to 0 gives you this bit of area, which would be negative in sign, and the integration from 0 to x will give you a positive value. Therefore, integrations from minus x to 0 will cancel off with the integrations from 0 to x. So this is a very useful fix to use when you are performing integration of an odd function. Therefore, in order to use this theorem 7, first you have to check whether you have a function. You would have to first check whether the function that you are integrating, is it even or is it odd? If it's even or odd, then you would be able to apply theorem 7. However, theorem 7 can only be applied if the integrations of the odd or even function is integrating from minus a to a. If you have a function that is either odd or even, and the integration is from minus a to a, then you can apply these two rules quite easily. Example 3. So you look at this function, x power 4 minus 4x squared plus 6. So you have to first check whether this function is even or is it odd. So to check whether a function like this is even or odd, what you do is you try to evaluate the function at minus x. So you replace all the x in the expressions of the function by minus x. Then you have these expressions plus 6. Now since the power in the functions or the integrating function are all raised to the even power, therefore replacing x by minus x do not cause any change in the values of the function. So here you get exactly the same as f of x. So a function that obeys this relationship, that is the f at minus x equals to f at x, then this is an even function. So now the even function is to be integrated from minus 2 to 2, then you can perform the integration quite easily. That is, instead of integrating from minus 2 to 2, you integrate from 0 to 2. And the integrations from 0 to 2 is easily obtained. This power 4, when you integrate, you got factor of 1 over 5, x power 4, then this term will give you this, and 6x is the antiderivative of 6. And you are going to evaluate it between 0 and 2, and you also don't forget about the factor of 2 outside. So since one of the limit has been converted to 0, then it makes your calculation slightly easy because you substitute 0 into all these terms, then it gives you 0. So you have to only need to evaluate the values of the function at x equals to 2, but you don't need to calculate the values of the function at x equals to 0. This is only can be applied to even function that is to be integrated from minus a to a. But you can't apply this, right? So you can't apply this and say that this is equals to x power 4 minus 4x squared plus 6 from 0 to 2. This is so because even though the function x power 4 minus 4x squared plus 6x is even, but the integration is not going from minus a to a. Therefore, you can't write this as 2 times. So this should be quite straightforwardly understood. Now let us try to look at an example of integrating an odd function. Let us look at a simple example of, say, x power 3. Now, x power 3 is an odd function, and let's just try to integrate this function from minus 1 to 1. Here, fx is x power 3, and if you evaluate f of x at minus x, then you get minus x raised to the power of 3, then you get minus x cubed. You come to the conclusion that f of minus x is just equals to negative of f of x. Therefore, the function x power 3 is an odd function. And if you integrate the odd function from minus a to a, then the answer is just 0. You don't even need to calculate what is the antiderivative of x power 3 because the integration itself will automatically give you 0 directly because the function is an odd function integrating from minus a to a. You can use this theorem number 7 to help you perform the odd integration without calculating it.